Welcome. In this video, we will learn about cost-benefit analysis or benefit-cost analysis, and it is applied in analyzing public projects. So we're doing here engineering economics. So a lot of public projects are engineering projects like highways, bridges, dams. And the idea here is you need to analyze these public projects, doing economical analysis to it and comparing between them economically. And public projects, there are projects that are funded by taxpayers' money and they are performed and the responsibility of public agencies. So examples of these, like cultural projects, museums, gardens or parks, protection, so military, security, economic services, so mainly the economic infrastructure, and then natural resources, wildlife in general, protecting wildlife and also protecting us human from natural resources. So flood protection is an example of that. So although that the purpose of public projects is not to make return or profit like private projects, but still economical aspects is a big deal in public projects. So to justify a public project, a big part of it is the economical aspect of it. So federal and state governments have their own ways of justifying economically projects, but on the federal level, you have that order or circular kind of direction from the White House. That's from 1992, and it's kind of providing guidelines and on discount rates and cost-benefit analysis or benefit-cost analysis for federal projects. On the state level, there are different state entities or agencies. So, for example, here I'm showing the California Department of Transportation or Caltrans, and they have their own primer or guidelines or performing benefit cost analysis. So benefit cost analysis or cost benefit analysis is the main method used to evaluate economic decisions of public projects from the economical perspective. So that's the definition from a resource shown here. So CBA is a way of assessing the desirability of projects economically by having a long view of the impacts of these projects and a wide view of these impacts on different sectors and different populations and different stakeholders. So the difference between public projects and private projects is that long view and wide view of assessment of the economical impact of such projects. And to use or apply a cost-benefit analysis, you have to figure out what's really the net cost and the net benefit of this project in monetary value. So in the US here, in dollar value. Everything should be brought down to dollars. And you represent it as cash flow, and you calculate then a cost-benefit metric to tell you, is this a project that's delivering benefits better than the cost that you invest in or not? So what do we mean by net costs? So it's the net cost to the agency responsible for the project. So if it's a highway in California, then it's Caltrans. What is the public agency or entity or the department or government that office in the government that's responsible for developing the project and financing it and building it? So net cost is equal to E, expense minus R, revenue. So net cost, E minus R. E is the expense or cost for the agency to build the project. And then R are the revenue that's generated or savings that are created by such a project. So a new system that Caltrans install that will save in its own operation, instead of using that many number of hours for staffing, you're cutting that and saving that. So that's considered revenue. So you focus only on the agency that's building the project. It's a public project, but you look at it kind of from the private perspective or the entity that develops that project. And then the net benefit equals benefits minus disbenefits. So benefits are the positive impacts of this project on public. And the public here, public groups, can be human or animals or wildlife, or it can be the environment in general. So you have to think about public, not only public us as human, but beyond that. So we're looking at the sustainability sphere here, that it's not only people, it's the environment, and the environment here includes the ecosystem and the habitat. This benefits is the same, but now you're looking at the negative impacts. So, for example, here this is a highway project for Caltrans. They will have to pay for the design and engineering. They have to pay for the land acquisition, acquiring the land for the project. They have to pay for construction, maintaining the project over the lifespan of that road, and then mitigation of that project and minimizing the impacts of it on the public. So you have sound barriers or noise barriers along the highway if it's cutting through dense populations. Revenue in the other case is that if Caltrans then collects money from the public for using that asset, public asset, the public already paid taxes to build this asset or paid in bonds, public bonds, but still kind of Caltrans saw that it's very expensive to have such a project, but it's important to have the project. So the difference that in financing will be covered by tolls, by fees that you pay at gates when you use highways. Or you can look at revenue by cost savings in current operations. Benefits and disbenefits for such a road. Benefits are shorter travel time, lower vehicle operation costs. So if it's a smooth road, your car is having less shaking, tires have less wear, so you're paying less for maintaining your car, less accidents, lower CO2 or emissions, greenhouse gas emissions. This benefits here, that's an interesting thing, is that the tolls here are counted as revenue for the agency, but they are counted as disbenefits here. Again, thinking about generally public finance for the projects in the traditional way through taxes or paying for bonds. So now that's now the extra thing that the agency here, Caltrans, asks for, which is tolls, is considered this benefit. Because typically I'm paying taxes for it, so why should I pay more for driving on highways? So that's not double counting. So that's pay attention to usually tolls or things that are collected from the public and goes into the funds of the public agency. This is kind of should be considered in the two perspectives, the net cost perspective and the net benefit perspective. And then there are other disbenefits. So the same way that the project or the highway will create shorter travel time for some people, it can cause trouble for other people and increase their travel time. So if a highway cut through a road that was traditionally kind of not cut, so people moving from the left or the east side of the road to the left, or the west side of the road, they didn't have to deal with ramps and all of that. So that increases their own travel time, but other people benefit from the project and they have shorter travel time. So the same project can create positive impacts on some stakeholders, people or animals or environment, and can create the same project can create negative impacts on other similar groups. So that's kind of giving you an idea that this is the wide view. You're considering all of these aspects, benefit and cost, and then this benefits, and then the net cost, there's the revenue and expenses. So if we think about benefits, kind of an exercise for you at home, is that think about for all these projects listed here, what would be a benefit for example, having an airport. So we're talking here, B is the net benefits. So actually, like, what are the benefits and disbenefits? So what would be a disbenefit for an airport? Probably pollution, right? So airplanes are one of the heavy sources of greenhouse gas emissions. Wildlife impacts, so wild birds and all of migration of birds may be impacted by it. So every project is unique, but of course, generally, an airport will have a typical benefits and disbenefits. So I'm giving some examples here just for you to practice and think. Just write down possible benefits and disbenefits. The challenging thing about CBA or cost benefit analysis is that requirement to have everything in dollar value. So net cost is pretty easy. You can use cost estimation techniques to figure out what's the expenses and revenue. It's something within the hands of the agency to set fees and kind of even estimate the savings in some operations. But the main challenge here is to really have this monetary value or valuation of the net benefits of such projects with such wide view and such long view of impacts. So just giving an example here, now we as engineers, we don't deal with that. There are economists who publish studies and spend years kind of having that monetary valuation of different aspects of our lives. So for example, this study here looked at the value of the ecosystem services. So like an ecosystem swarms, what services it provides, and they kind of went in detail in financial models and economical models. What's the dollar value for every hectare of such a swamp or for a coral reefs? So once you have a dollar value, then you can estimate and have that dollar amount in your cash flow and in your cost benefit analysis. That's one example, like natural habitat or ecosystem landscape. Another one is projects that impacts people and saves people lives or maybe cause the other thing. So here, one concept is called value of statistical life, VSL. So what's the value of a person's life? What's my value? What's the value of my life? What's the value of your life? What's the value of someone in another state? What's the value of the life of someone in another country? So that's a very tough question because no one can put a dollar amount for the value of someone's life. It should be priceless, right? But still, you have to quantify it. So federal agencies here like EPA, Environmental Protection Agency, so all of these example of agency, Federal Aviation Administration, FAA, DOT, Department of Transportation. So all of these have their own in-house kind of guidelines, and they kind of suggest values for VSL. And this chart here shows the trends, and you can see here in the US, the VSL value ranges between like 5 million, which is for the green one here, is for CPSC, Consumer Product Safety Commission. So from 5 million all the way to 9 million. So kind of an average is 7 million, maybe. So 7 million average is the value of life of each one of us in the US here. This is another study that shows differences in even people estimating VSL, but even differences and they acknowledge that the age of people makes a difference. So the value of people when they are really young, so there is no much investment in them in terms of education and learning and experience, their value is not that high. But then the more experience and the more contribution they have to the economy and the society, their value increases. And then when they get older, again, that's very harsh discussion here, but economically, this is how by money, by numbers, they quantify. So when you get older, you don't have much time to contribute to society and economy. So that's how they see that your value is going down. So they look at us as machines, basically, and they put dollar tags for our life or on us, and this dollar tag changes with time. So that's another study here that shows us. And even the mind-boggling kind of thing is that the VSL, that value of statistical life, is dramatically different between countries. And you can guess that the VSL in developing or developed countries like North America or Europe is much higher than the rest of the world, which is mostly developing countries. So this table here from the study shows that best estimate here in thousands of dollars, and it's a pretty old study here, 1995 or 1997. So you in North America here, the United States, the value here is around 3.7, pretty close, 3.7 million, pretty close to the number we like. I remember this is a pretty old study, so with inflation, all of that. So with inflation, it should be close to the number like 7 million that we had in the previous slide. But compare that to the other countries, like the lowest country here, you will probably see that 360,000. That's Peru. So unfortunately, I mean, it's not kind of it's not just, of course, like a human life is a human life, but from economics perspective, there are dollar valuation for people's life depending on their contribution to the GDP, or what we call in country. Every country has a gross domestic production. So how much production does this country have? And they split that over the population of the country, and they figure out kind of that's the VSL of every person in this country. So very materialistic for sure approach of quantifying the impacts of lives, but that's economy. That's how people deal with economy here. Another example here is quantifying the environmental impact of projects. So greenhouse gas emissions. So that's from this. It's from APA, Environmental Protection Agency website, that gives tables and tables of the cost of different greenhouse gas emissions. This is one of them, which is CO2, and you can see here the and of course it increases with from now up to 2050 because of the inflation, but this is kind of the average here. Currently in 2020, it's around $42 per every metric ton of CO2. That's the cost. So when you evaluate a project, you look at how much embodied CO2 in its material that you use. So you compare between, for example, steel and concrete. There are a lot of references out there that will tell you in this much cubic yards of concrete, you have this much cubic CO2 embodied into it. And then you can translate that into dollars. Also, during the life of the project, how many energy it consumes. And so there are a lot of detailed calculations you can figure out to see how much greenhouse gas emissions it generates over its lifespan, and then translate that using the tables from APA into dollar values. So this is just a glimpse into the difficulties and challenges of dealing with CBA, especially the dollar valuation of the benefits and disbenefits of projects. So let's see this example here of, so as engineering economics, we're not dealing with all of that. So we assume that these numbers are given to us. Someone had that exercise of doing all of that estimation of net costs, revenue, expenses, and net benefits, benefits, and disbenefits. So there's someone have done that for a dam project. So as an initial investment, you have all these expenses. You have to build the dam. There's some hydroelectric components to it and transmission. So it has some power generation here. You have to relocate the highway. You have to acquire land. So all of this is the initial investment. You have to operate the dam. So it's 5% of all of that above. There is annual income from the project to the agency building the dam from the power, the energy they generate. And then there are annual benefits to the public. So reduction in flood, enhancement of property value, because now you have that reservoir made by the dam. So you're increasing the property values around it. And then value of customers having power available. So those who did not have power by a public utility, now they have access to it. So if you start now labeling these, which one is expense, which one is revenue, which one is benefit, which one is this benefit, so that will be here the outcome. So if you add up all the values in under investment, that will be 79.5 million. That's kind of a cheap dam in today's dollars, but that's just an example here. And then operation and maintenance is 5% of that, so you end up with around $4 million. The revenue is the fees that this agency will benefit from creating that power or generation and selling it. So you have this amount. Benefits here, if you add up all the benefits from flood protection and all of that, that will be the value of total benefits. Now remember, people who paying now power, they used to have it before. Of course, this is debatable. Like power, I always pay for power. Maybe highway, I'm not used to pay for it. But typically, if you have a revenue that's collected directly from an agency for making a public project, then that revenue that's created because of this project is considered a disbenefit to the public. Every project is different. In this case here, we're counting it as a disbenefit. So that same 9.5 million per year from selling power to customers, it's kind of a disbenefit for these customers that maybe we're expecting to have it as a free power or maybe reduced. Or this is kind of the breakdown of the benefits and disbenefits we have. After you kind of break down and classify the different components here into B and C kind of buckets, you need to perform calculations here. For us in this course here, we will evaluate we will use hand calculations here for sure. Cost-benefit analysis can also be used to compare between alternatives. So it's not only one project. So in the planning phases of a project, you have planning studies, and these planning studies will say build this dam this way or this way. So you will do now different two CBA cost-benefit analysis for these two alternatives, and pick the one that gives you the benefit-cost ratio, which we'll see how it's calculated. Also, there is incremental cost-benefit analysis. So if you have one option you're thinking about, there is always the option of doing nothing. So if this is kind of the road that you currently have, and you're trying to build this highway here, or change the way or the route of it, you always think about what's the incremental benefits and incremental disbenefits compared to do nothing. So it's kind of delta. So you delta in accidents. So how many people will be, like how many less accidents you'll have, how many savings in life you'll have. So that incremental or delta kind of approach to costs and benefits can be also done here. So cost-benefit analysis or benefit cost analysis, you will do it to end up with possibly two values, either a ratio or a dollar value. And you will have everything represented, like we said, as a dollar amount or monetary value for every benefit, net benefit and net cost that you have. So the formula for benefit cost ratio. So benefit cost formula here is given in that kind of formula, but it's basically here for every net benefit cash flow in a year, you're discounting it. So this kind of value here is kind of the P given F factor. So you're bringing everything to the present, and this is why kind of the shorter version or the simple version of this is that basically benefit cost ratio is the ratio between present worth of a net benefit, of all the net benefits you have, and the present worth of the net costs you have. And similarly, like the idea here, you bring the worth of benefits and the worth of costs as apple to apple. So here it's present worth, but you can apply future worth. You can calculate future worth of benefits and future worth of costs and net costs, and get the ratio and between them, or you can use the annual worth in this case also. And a project will be favorable if your benefit cost ratio is more than 1. Instead of a ratio, you can figure out the difference between benefit and cost values. In this case here, we're using also present worth. So the difference between present worth of net benefits and the present worth of the net costs. And of course, this B minus C ratio value, if it's more than 0, then this project provides more benefits than it costs. So let's see this example again. After we kind of categorize the different values we have, we need first to see if this project pays for itself without considering the benefit side. So we're only looking at this side here and see, is it really worth it if it's kind of a private project? And then we'll look at calculating the benefit cost ratio, and we'll also kind of calculate the benefit minus cost value, and then determine at the end, is this project favorable or not favorable. So we have here, first thing is we need to represent our problem as cash flow. But here we have two cash flows. We have the net cost cash flow and the net benefit cash flow. So this table will just represent it here graphically. So the first one here, the investment, around 80 million, happening at time 0. And then you have the maintenance, operation and maintenance costs around 4 million. And then annually you have the power generation and payments and income you have from that. That's the net cost cash flow, or you can call it the agency cash flow. The next will be the public cash flow, or the net benefit cash flow. So you have here the benefits around 13.6 million, and then the disbenefits like here 9.5 million. And you see 9.5 million are disbenefits for the public, but they are revenue for the agency. So that's the 3.6 benefits million and 9.5 million disbenefits. So we'll agree here that we'll use present worth for calculating benefit and cost components here. And if we focus on the net cost cash flow, for me, kind of just to make sure I'm using the value correctly, I will label E and R. So E are expenses and R are revenue parts of this cash flow. And I'll calculate the present worth of expenses. So I have here the initial investment and then the operation and maintenance. Initial investment is already a present value, so multiplied by 1. And then the operation and maintenance is multiplied by a P given A factor, 8% and 50 years. So when you bring the factor here, value, P given A value, you end up with this present worth of the expenses. And then you will do the same for the revenue, for the 9.5 million here, multiplied by the same P given A factor, and you end up with this value for the revenue. So now your net costs will be, the C will be equal to E minus R, or the present worth of E minus the present worth of R, and you end up with this net cost for this project. And then net benefit will be focused on the public cash flow. And here you have a very simple cash flow. You have the benefits, and we'll calculate here the present worth for them. And 13.6 million, this is around 13.6 times the P given A, the same factor P given A we used before. And the present worth of this benefits will be able also to calculate it. And then the net benefits will be benefits minus this benefits, or the difference between their present worth. And now we have B and we have C, so we will be able to calculate B over C ratio, or B minus C value. But before that, if you look at C, remember, it's E minus R, so it's not the traditional way of looking at numbers here. It's the outflow minus inflow. So it's kind of in traditional economical problem in private projects, it will be a negative value. But here we label it cost. So we just figure out here that it's equal to the expense minus the revenue. And now cost is more than 0, meaning that the project costs more than it creates revenue for the public agency, which is a very typical. Actually, a public project should not create a revenue more than it costs for the agency responsible for it. And this is just an explaining here that if you analyzing this project from just pure perspective of economics, for just focusing on the agency, what's the revenue and what's the cost, it will not be justifiable. You cannot justify it, but you have to look at the benefits and compare benefits to cost. So here, just reinforcing that idea, public projects are not built for revenue. Typically, if there is a revenue, it will not be even like enough to cover part of the cost or expenses that the agency deals with. Part B here was asking about benefit cost ratio, so you will just dividing B over C, and you end up here with B-C ratio of around 4.2, and that's pretty good. And if you calculate the B minus C, the difference between B and C will end up with positive value here. So in summary here, we can say that this project is really favorable. It's providing benefits 4 times the amount of costs, net costs of the agency, and it provides a positive difference between benefits and costs, B minus C. So that's the end of this exercise. Kind of it's showing you how the economics analysis and cash flow analysis for a project, but remember, the numbers provided to us has a lot of work involved in trying to estimate all of these numbers, especially the benefits and disbenefits. So that's the end of this lesson here. We'll learn about cost-benefit analysis or benefit-cost analysis, the process of developing the benefit and cost estimates. We're just learning about it, how it's done, but it's a big field that requires a lot of studying and researching. But we also looked at how we quantify the different metrics of the CBA. So you have the benefit cost ratio, or if you look at the benefit minus cost value, this is another way of developing a metric that will help you to make a decision about public projects. All right, so that's it. Take care, and I will see you in other videos.